Hello everyone. Now today we are going to see the remaining topic from our viewing transformation, and in last video lecture we have seen what is the concept of viewing transformation. Now today we are going to cover this viewing transformation with one example. So let's start with this. So we are going to cover the topic viewing transformation example. Before that we will revise what is this viewing transformation. Already we have seen this contents in previous video lecture. This viewing transformation is nothing but whenever we want to convert our world coordinate into the device coordinate. Why we are converting? Because the world coordinates are nothing but the actual scale of that particular object. For example, in kilometers or millimeters, etc. Right? So these are the actual scale, but these scales we cannot represent it as it is on the screen. So that's why we are giving or representing them in the form of coordinates, right? So we are transforming that world coordinate into the device coordinate or a screen coordinate. So we are going to represent them into the screen coordinates whenever we are representing them with a image model. So whatever the object we are storing, that is called as object space, and then we are going to represent that particular object by using this device coordinate in, like an image model or image space, right. So this transformation from this world coordinate to device coordinate is nothing but viewing transformation. So sometimes it is also called as a window viewport transformation or windowing transformation. So these are the synonyms for this viewing transformation. This viewing transformation having 3 steps. We have actually seen these 3 steps, that is translation, scaling, and again the translation. So these are the 3 basic steps while we are doing this viewing transformation for any particular object. So step number 1, with that we have an object with its window, and that window will shifted or translated. Translation words contain a translated. We are going to translate or shift that window until the left corner, lower left corner of that window will matches to the origin of our coordinate system. So how we are going to do that? So this is what a window, and if I want to shift or translate that window to the origin of this coordinate system. So this is what the lower left of this window, which is matching with this origin of our coordinate system. So this translation we are doing from here to here. So from here we are translating window to this particular point. So what we are going to shift now? Here we are shifting a lower left corner of that particular window. So this is what our step number 1. Then in step number 2, we are going to scale that window such that we can convert that dimension of the scales into the dimensions of viewport. Why we are converting them into the viewport? Because whenever we are showing a particular object, that objects are always having its original dimensions, right. And whenever we are converting them into the coordinate, another coordinates which we want to display onto the particular screen, so we are going to convert them into the screen coordinate. Now it may happen that if we want to represent that particular object onto this screen, at that time we are not utilizing the whole area of a screen. We just want to show that part on a particular part of that particular screen, right. So that portion of the screen is selected by that viewport, means for this portion I want to select, for this portion I am going to display that particular image. So these are the things, right. These are the things which we are going to do. So what the window refer over here? Window is nothing but what is we want to view, and the clipping is nothing but which part we want to omit. Means now in this window only this part is visible, so I want to omit or suppress all the part which is outside of that window. And then viewport, that defines where it is to be displayed on a display device. So where we have to display that particular image, that we are going to show with the viewports. That's why we are going to convert this window coordinates into the viewport coordinates. So how we are going to convert that? By using this scaling, we are converting this window coordinates into the viewport coordinates. So they are scaled according to the portion of the screen, according to where you want to display that particular object. As per that we are going to scale that particular object. Now the next step is, after translation scaling, again we have to do translation. Why? Because first of all we have shifted our window to origin. Now again I want to shift that window to its original place, right. So another translation is to move the viewport to its correct position on the screen. So we want to move this viewport. So in this way we are going to move the viewport, or we are placing the viewport where I want to place onto the screen. So in this way we are doing this translation, scaling and translation. So now this we are going to see by using one example. So what is the example here? Suppose there is a rectangle ABCD whose coordinates are given as a 1, 1, B 4, 1, C 4, 4 and D 1, 4. Now with that we are again having a window coordinates 2, 2, 5, 2, 5, 5, 2, 5, and the viewport location is also given. Now we have to derive the transformation matrix, right. So at this time it may happen that all of you do not know what is the transformation matrix. Why? Because we have not seen the transformation yet, right. We have just have an introduction of scaling, rotation and translation in the unit number 1 where we have covered the topic called as OpenGL. We have seen this concept, but how this transformation matrix are formed, that we are going to see in our next unit. Okay. So now at this time you just remember what is the transformation matrix is and how this matrix are derived. We are going to see this derivation in the next unit. Okay. So here we are just having a one example related to this weaving transformation, that is why we are representing them into the form of matrix. So you just need to concentrate on the matrix value here only. So now what I want to do, I want to draw a rectangle first of all, and the rectangle is given as a ABCD. With that rectangle we are having a window coordinates also. So we are going to draw this. So what is our rectangle coordinates? These are coordinates. So I am plotting this coordinates on this coordinate system. So 1, 1, this is my first point called as a 1, 1, right. So this is a 1, 1. Then the next point is 4, 1. So this is what a 4, 1, then 4, 4 and the 1, 4. So these are my 4 coordinates. So in this way I have plotted this rectangle. After this plotting of this rectangle, the next thing we are having a window coordinates, right. With this rectangle we are having a window coordinates. So now I have to represent this window coordinates with the given values. So how I am going to represent? So in this way, so the first thing is 2, 2, then 5, 2, next is 5, this is 5, 2, then 5, 5 and with that 2, 5. So these are the window coordinates. So I am representing this window as a dotted line, right, a dotted box, and this rectangle as a solid lines, right. Now what I have to do, with that again the viewport location is also given here. We are going to use this viewport location whenever we are converting our window to viewport. So what we have to perform over here, the 3 steps, that is translation, scaling and translation. So now here we are not going to show it diagrammatically, but we are going to show in this form of transformation matrix, because here it is given that you have to derive the weaving transformation matrix. So we are going to represent this diagram in the form of matrix. So how? Just see. Now the first step we have to do a translation over here. So what we are going to do, we are shifting our lower left corner of our window to the origin. This is our first translation. In first translation what we are going to do, we are just shifting our window to the corner or lower left corner of that window to the origin of our coordinate system. So how we are representing? Here is actual diagram given that we have drawn in the previous slide. Now I want to shift that window. So how I am going to shift that window? I want to shift this lower left corner to this origin, right. So here is our origin. So I want to shift this lower left corner to this origin. So how I am going to shifting that? So for that what I will do, whatever the coordinates we are having at this particular point, I will make -2 from each x and y coordinate, right. So if it is having the value 2, 2, right. This is a value 2, 2. So I want to shift at 0, 0. So what I am going to do? 2 minus the we are going to shift it by 2, right. So 2 minus 2 I will get 0, 2 minus 2 0. So, now I will reach to the 0 comma 0. So, what I have to do? I have to make a minus 2 from each coordinate x and y. So, thus I am going to do here with this window coordinate. I will take the first coordinate, that is 2 comma 2. Why I am taking this first coordinate? Because I want to focus on the lower left corner of our window, which is the lower left corner, this 2 comma 2. So, what I am going to do? I want here a 0 comma 0. So, I am making here, you can see this is the place in a matrix where you have to represent the x translation, x coordinate translation, and here I am representing the y coordinate translation always. Always we have to represent here as a tx, that is x coordinate translation, and ty, that is y coordinate translation. So, by which value I have to translate my x coordinate? Minus 2, means we have to make the subtraction of a 2 value, because I want to reach to origin, right. So, from the x coordinate I am making a minus, I am subtracting the 2, again from this y value I am subtracting the 2. So, here we are representing a translation value at the third row and the first 2 column. Okay. So, in this way now you can see here this window is now translated towards the origin. So, here we are having a origin point, right. So, now my window is translated to origin. So, this is what the first translation state. Now, the second is the scaling. Now, we are going to represent the scaling in the form of matrix. So, what is the scaling? We have to scale a window to viewport, because I want to represent this object onto the screen. So, I need to map whatever in between that window that we have to show onto the screen. So, what is in between our window? Window contains this much portion, right. Window is containing this much portion. So, I want to show the portion which is within a window, right. So, that portion how I am going to show? I will convert that window into the viewport coordinate. So, for that particular we need a scaling. Here the old dimensions will be of window dimension, and whatever we are calculating new dimension, that all dimensions will be of viewport, okay, that will belongs to the viewport. Now, here the both coordinates we can have, that is viewport location is also given on the screen. This will be the viewport location, and the for a window coordinates, these are the coordinates. Now, I will find out the x direction scaling. How much we have to scale our x direction, how much we have to scale our y direction, that we are going to find out in terms of Sx and Sy. Okay. So, here Sx are showing that new coordinate, new divided by old. What is the new? That is nothing but the view. New means we are mapping from window to viewport. So, viewport is new and window is old, right. So, new is nothing but whatever the width of viewport and the width of window. So, what is the width of viewport? How we are going to find out the width of viewport? High minus low. What is the high of viewport? This 1 will be high, right, and this 0.45 will be low. How I am going to find out that? Because width is given by the x coordinate. So, I am just considering the what is the high value of x coordinate? 0.5, 1, 1 and 0.5. Which is the high value? 1. Which is the low value? 0.5. That is why 1 minus 0.5 is equal to 0.5. So, this is what the width. Okay. Now, I have to find out the width of window. Why I am finding the width over here? Because we want to find out the scaling in x direction, and in x direction we are finding the width. That is why I am finding out the width of viewport and width of window. The same way we have to find the width of window. So, find out the x coordinate 2, 5, 5 and 2. So, high is 5, low is 2. So, 5 minus 2 is equal to 3. So, this is giving as a 0.16. So, scaling in x direction will be 0.16. Same way we have to find out the scaling in the y direction, which is represented as Sy, which is equal to the height of viewport divided by height of window, because the y coordinate is representing the height. Now, here I am going to represent that with the height. So, how we are representing height of viewport? So, what is the height? Now, I am going to see the y coordinate. So, what is the y coordinate? 0, 0, 0.5, 0.5. So, which is the high value? 0.5, and low value we have to minus it. So, height will be 1 minus 0.5 Actually it should be 0.5 minus 0 is equal to 0. There should be a one correction, that is high value is 0.5 and the low value is 0. So, it should be 0.5 minus 0 is equal to 0.5, right. And then the height of window is 255. So, 5 is max, 2 is mean. So, here high minus low is equal to 3. Now, it is again going to represent Sy as a 0.16. So, we are getting 2 value. Now, where we have to represent this 2 value into the matrix? Whenever I am considering the translation, so at that time I am giving here as a Tx and Ty. Now, this Sx and Sy are given over here at a diagonal position. So, here it will be Sx, here it will be Sy. So, 0.16, 0.16. So, this is my scaling matrix. So, this is what the matrix for a scaling purpose. Now, last one is a translation. Wow, what a translation this? The third translation we are using to translate our viewport to be desired location on the screen, where I want to translate that at that particular location I have to translate that viewport. For that particular we are having this viewport location. So, what is this scaling is here now, where we have to translate. So, whenever we are translating anything, what we are translating, the lower left corner of our window, right, lower left corner of viewport or lower left corner of window. So, which is the lower left corner here? The 0.5 comma 0, this is what the lower left corner. So, how you are translating? By the half distance in x direction and 0 means y will be same, only x is translated, right, by the value of 0.5. So, how we are going to represent in the translation matrix? So, here is my x coordinate which is translated, here is a y coordinate which is translated. So, x coordinate is 0.5, y coordinate is a 0. So, this is my translation matrix. This all matrix we are going to see in our upcoming unit, next unit, but here is only some introductory part of this, that is why we are saying. So, here is a Tx and here is Ty. Okay. So, this is what we have done. So, we have found out all the 3 translation matrix for a given example. Here we are finishing with our example, we just need to find out the matrix. But what we can do, one thing is we can have this overall transformation of a matrix by taking the multiplication of this translation with respect to window, scaling matrix and translation matrix with respect to viewport. What I am saying? I can take the multiplication of all these 3 matrix. Which are the 3 matrix? The first translation matrix which is with respect to window, second is scaling matrix and again third translation matrix with respect to viewport. The first translation is for window and the third translation is for viewport, right. So, in this way I can represent. So, what is the matrix? This is what the translation matrix for window that we have founded previously, right. Then this is what the scaling matrix we have founded and next is a translation matrix for a viewports. So, I can multiply all these 3 matrix and then we can get the final viewing transformation like this. So, we have to multiply this translation, scaling and translation matrix over here. Okay. So, there is one shortcut method also for doing this. What is the method? Means instead of doing this all what we are saying, this multiplication of 3 matrix, we can have a shortcut matrix to represent this multiplication. How? Let us see. Now, if we want to multiply the rectangle ABCD with the matrix, then we will get a desired output at specified position onto the screen. Okay. So, we can have a direct derivation for this instead of making the multiplication of this all 3 matrix. So, here we are using 2 symbols. First symbol is W, that will represent the window and the next is a V that is going to be represent and viewport coordinates. So, W will represent the window coordinates and V is going to be represent the viewport coordinates. Now, here you can see this is what a window we are having, this is what a viewport. What these coordinates are representing? This is what the WXL and WYL means. This is the lower x coordinate, this is a lower y coordinate. Here it will be WXH and WYL. Here the higher x coordinate, because the value of x is changed, but the value of y will be same, that is lower, right. So, you can see this in form of coordinate system. It will be better to show this in the form of coordinate system. Now, here you can see this is what your x, this is what your higher x, this is lower y and this is higher y. So, what we are having here, lower x and lower y. What we are having here, lower x, lower y coordinate, higher x, lower y coordinate, then higher x coordinate, higher y coordinate, and here the lower x coordinate and higher y coordinate, right. So, in this way I am representing the window. Same coordinates will be there for this viewport, but only the we have to show it by v, right. Okay. So, these are the window coordinates, these are the viewport coordinate. What this WXL and WYL shows? It represents the window's lower left corner. This is what the required thing for this whole translation, that is lower left corner. So, WXL and WYL will be showing a window's lower left corner, whereas this VXL and VYL are represents the viewport lower left corner. Both are required for this viewing transformation process. Now, the matrix translation with respect to window will be. So, first we are going to see a translation with respect to window. So, what is the window coordinate lower left? Lower left coordinates are this WXL and WYL, and what I am going to do? I am shifting this to the origin. That is why I am taking it as -1. Shifting towards origin means what we are doing here? We are making or we are subtracting something from that particular x, means we are decreasing the value of x, simultaneously we are decreasing the value of y. That is why we have taken it as a minus and minus. We are making changes in this x value as well as in the y value. So, this is what the first translation matrix. The scaling matrix will be like Sx, Sy and 1. So, for this diagonal element it is as a 1 1 1, but instead of 1 I am putting as a Sx and Sy. So, in this way we are representing the matrix as a Sx, Sy and 1. Now, we have to find out the scaling in x direction, that is nothing but width of viewport and width of window. So, how I am going to represent the width of viewport? The highest x coordinate of viewport minus lower x coordinate of viewport divided by highest x coordinate of window minus lowest x coordinate of that window. So, in this way I am representing the width, as well as height will be represented as a the highest height minus highest height of the viewport minus the lowest height of viewport divided by highest height of the window divided by the lowest height of that window. So, in this way I am representing this. What I am doing? I am just representing in terms of WXL and WYL and VXL and VYL. Why? Because we have to make it generalized. Always we are not going to find out 3 matrix and then multiplying all the matrix. We are having one shortcut method in terms of this WXH and WXL likewise. Okay. So, here we are we can have this scaling matrix. So, Sx I am putting over here, the value of Sx will be here, and this is what the value of Sx. So, I am putting that value of Sx over here, and this is what the value of Sy, that value I am putting over here. So, this will be my scaling matrix. After that after this scaling matrix, what I am going to do? Third matrix, that is translation matrix with respect to viewport. Okay. Now, this translation matrix is for viewport, the first translation matrix is for window. Now, with this translation matrix I am going to represent this VXL and VYL. Now, you can ask the question like, in that first translation matrix we are representing it as a minus and minus. So, why I am representing this as a plus? Because I am shifting from that origin towards now where we want to show. So, this is like we are increasing our x and y coordinate, and that is why it is represented as a plus plus. Okay. Now, we can collect all this matrix at a once, right, to form the generalized matrix. So, what I will do? In that example, what I have done? I have taken the multiplication of that translation, scaling and translation. Same thing, this is what the first translation matrix with respect to window, this is what the scaling matrix which I have derived, and the next one is again translation matrix with respect to viewport. So, I will take a multiplication of all. Now, I am just assuming here that all of you know what is the multiplication of matrix is. What we are doing in multiplication of this matrix? We are multiplying the row with a column of another. We will take the row of first matrix and the column of another matrix. For example, 1 with this term is equal to this term plus 0 into 0 0 plus 0 into 0 0. So, this term plus 0 is going to represent the term itself. Okay. Same thing, now the first row, second column, 1 into 0 0, 0 into this term 0, 0 into 0 0. So, 0 plus 0 plus 0, so it is going to be represent as 0. Means in this way you have to first of all find out the multiplication of this and this matrix, and again whatever the matrix you have formed, again you have to multiply that with this matrix. So, after giving solving this, I am not going to explain the whole solution of this. But after solving this matrix, we are getting a matrix like this. Now, we can directly put the coordinate value over here, and we will get the final answer of our question. So, instead of making finding out the 3 matrix and then multiplying all of 3, you can have this matrix directly, and you can put a value of coordinates, that is lower left and lower right and etc. over here. Then you will get a final answer of this translation or a transformation matrix. So, this is what the method in which we are having a generalized matrix over here for the weaving transformation. So, we can also use this generalized matrix over here. We just need to keep in mind what is the value of this rows and column. Okay. So, these are the questions on this weaving transformation, same questions from the yesterday, only we are not covered with an example. So, this is what the part we have covered today, that weaving transformation with an example. So, today we are going to stop over here. Thank you all of you.